Well, my name is Eric Burgoyne. I'm a graduate student in the Department of Technology and Environmental Design at Appalachian State University, a very rare academic environment in the scope of higher education. I'm pursuing a degree in building science, and next to me is Mark Bridges.
I'm Mark Bridges. I'm the communications manager for our project. I got my undergraduate in architectural technology and design, and I'm currently getting my master's in sustainable design and construction.
And basically what we're here representing is our Solar Decathlon Europe project. I don't know if anybody quite knows what the Solar Decathlon Europe is, or Solar Decathlon is, but Mark will go into greater detail. But it's an international competition where 20 teams from around the globe are selected to design, construct, and engineer an Energy Plus home. Those 20 homes are then brought to a central competition site and compete against each other, basically simulating the life of a family of four in both consumption and production data for a period of 3 weeks. It's called the Decathlon because you have 10 contests. Whoever gets the most points at the end of the day has built the most sustainable home. This was started in 2002 by the U.S. Department of Energy and has taken off. Currently, there's 3 decathlons in the world. There's the European, going to happen this summer in Versailles. I want to see everybody there at our house. There's the Chinese, just wrapped up in August, and I forget the city it was when. And then, just in October, there was the U.S. Decathlon, which happened in Irvine, California. And many of the companies that are in this one quadrant have many products that were involved in those houses. But without much more ado, I'm going to turn it over to Mark. He's going to give you a small recap of that and get us introduced. And I'm going to take a seat in this chair, Mark.
All right. And as Eric sits down, watch him as he moves off stage. He's our sponsorship manager. He's very good at his job, so know what you have in your pockets before you leave here. What's on screen now is a graffiti mural in our target market in central North Carolina. And as an academic exercise, you don't really understand when you go into these target markets, you're building these homes for these people. And when we sat down with a housing authority, they said that they have 4,500 people waiting in line to get housing there. And then when we went out and walked the streets, we saw this. We demand decent housing now, so it really hit home that the people in our target market that we are helping to build homes for really need and deserve what we're designing. Who we are Team Reciprocity. We are a continuation and a highlight of a 30-year partnership between Appalachian State University in Western North Carolina and University of Angers in Angers, France. Now, part of our project, yes, it is to build a home, but if you build a home and don't get the word about what you're doing, it's kind of pointless. So what we developed was SEED, Sustainable Evolution Through Education and Development. It challenges us to rethink, relive, and reimagine our social environment. And through our aspirations, and over the course of this project, professors, students, and industry professionals will work together to provide the educational opportunities and the sustainable lifestyle developments to prepare decathletes to be truly global citizens to successfully impact their fields and communities. And also courtier reciprocity, because right now we're building our prototype, which is a 2-story home, Maison Reciprocity, but part of what we're challenged is, how is this home can be scaled up and into a community? This is one of our faculty. He's a licensed engineer, very goofy. We have great faculty that lead this project. And we actually have one here right now, Chuck Perry. He is the program manager for North Carolina Energy Efficiency Association. He has his own company, Perry Built. And like I said, he's our GC. We're students. A lot of us don't have a ton of building experience, so he caters to our stupid questions and also our very good questions. So we really appreciate what Chuck has been doing for us over the last almost year of this project. We dress well when we do construction. This is our interior designer as she helps bolt in one of the walls. This is Eric Burgoyne. We do lead tours to students to teach upcoming students about what we're doing and how it's going to affect them later on. And then sometimes we don't enjoy what we do. What is the Solar Decathlon? It spurred in 2002 from North Carolina for a need for research and development in alternative energy efficiencies, particularly solar power. It challenges students to build, operate, and design a home that is market viable and that can be scaled to larger production. And as Eric went through, these are the 10 categories below that we're judged in. And 2010, it moved to Europe. And this program evolves over time. It started with the homes are allowed 15 kilowatts of photovoltaic array on the home to 2012, where it moved to 10 kilowatts, and now we are only allotted 5 kilowatts of power to use to power these homes.
Just a quick note, on an average note, that would produce about 15,000 kilowatt hours a year. The average home in the U.S. uses much more than 15,000 kilowatt hours a year, so we are building a much more energy efficient home than the standard market demands or that we see in the U.S. currently.
All right, Solar Homestead 2011. This was our U.S. entry, and in the U.S., the homes focus on how the homes operate in and of themselves. But in Solar Decathlon Europe, they focus on how to use your home scaled up and fit within a community setting. And I bring up the sponsor below because it brings up two things, relationships and products. Relationships, Plygym has done so much for us. Being such a large company, they have sat down with us. What do you need? How do you want it? And is able to have our needs met. And then the product. These doors that they are providing in the frames will be the first thing you see coming into the house and the last thing you see leaving the home. Maison Reciprocity, who we are. Our home is a row house. It is a building vernacular that has spanned generations and cultures to prove its effective density with its 0 lot lines and shared adiabatic walls. And we're bringing it back into the 21st century by reimagining it with more efficient construction methods, affordable technologies, and healthy materials. And scope. Our total project cost, we are an unsubsidized team, so we're looking at raising $1.4 million to fund the entire home.
The best building market that we've ever seen, right? A lot of money floating around these days.
And then weather. We are outside, snow, rain, ice. Last week was negative 35 with wind, and it's been 105 last summer. Student involvement. We're looking at 1,700 students from Appalachian State and about 500 from University of Angers. Materials and construction. We are using a construction method that is not very much seen here in the U.S. It's cross-laminated timbers. These panels range from 500 to 2,000 pounds. And so you have students that are unsure about moving these materials, but we're getting it done. And also our home is constructed of 6 modules. As you can see on the bottom of the screen, that's one of them. And these range from 10,000 to about 15,000 pounds. This is a typical lot. An average yard in the US is about 30,000 square feet. On the top is the footprint of a single-story home. On the bottom is the footprint of a 2-story home. Now you take this, add in a retail shop averaging 1,200 square feet, you get this, Maison Cordier. In that same 60,000 square lot, I can get 15 Maison Reciprocities. And on the right, you see that on the bottom level would be a retail shop or a universally accessible area. The next 2 light blue areas are habitable spaces, and on the top is a terrace. Now the cost. What you're looking at, the $351,000, is our prototype. It is a spec house. You're not going to spend $100,000 on windows and doors. On the bottom is Cordier Reciprocity, and right now we're in a preliminary cost-benefit analysis that's looking at pushing this home at about $120 a square foot with a 4 to 6 year payback. But the reason we're able to do this, to offset the high upfront costs of those energy efficient systems and the new materials, is drastically reduced construction time and drastically reduced labor. This is our target market. What we're looking at in an application of this home is first-time entry-level home buyers. And what you can see is major roads, paved versus public, paved versus built. So we're doing a lot of research into how to most effectively apply this home. And with that, I'll turn it over to Eric to talk about our innovative technologies.
So an interesting couple facts. I'm a self-proclaimed energy geek. I learned a lot of my energy knowledge from Chuck Perry. But the bottom line of this is, right, our consumers in the U.S. are reassessing what we see as a quality home. And a quality home used to be what it looks like. Now, in the state of North Carolina, we're seeing that people are demanding an energy efficient and a visually appealing home. The state of North Carolina has now required that all homes get a HERS score. We've effectively, in the state of North Carolina, given a home a miles per gallon rating, which is going to be listed on the multiple listing service, so consumers can now look at a home's energy consumption right on the listing. So the younger home buyers are asking for this. The disconnect that our department studies is why are we not supplying it? How can we get energy efficient homes into the marketplace? Not net zero. Net zero is coming along. I will own a net zero home one day, I guarantee it. But energy efficient homes, what is the new standard on that? The interesting thing that I wanted to bring up that Mark also mentioned is a 4 to 6 year payback period. Does anybody in this group know the national average for ownership of a home? How many years? The biggest, 5 years. Well, I'm gonna help myself out. I'm gonna say 7. I've heard 7 a lot, and I've looked up 7. 7 years. And the biggest thing was to build a net zero home was a 9-year payback. It made no sense. I'm not gonna own it long enough. With $120 per square foot and a 4 to 6 year payback period, we are in the target market where you could see an economic value. Now, let's not even get into the conversation of why we only own homes in the US for 5 years. That's a little ridiculous all in itself, but it's good for our industry, so I'm going to keep pushing it. So when we looked at what consumes energy in homes, what consumes energy and what leaks energy, where do we produce the energy and where does the energy get wasted? The biggest thing is mechanical systems. We, in this industry, have great engineers that design very complex mechanical systems, and then the oversight leaves as soon as the plans leave the door. So how do we make sure that we size HVAC appropriately? You know, I can't tell you how often you go to a job site and you're still using the rule of thumb, 1 ton per 650 square feet. Why do you want to do that? So what we've established is what we call a CORD, the Container for High Performance Operation, Distribution, and Recirculation. The engineers really like it. Basically what we did is we took 2 of our 6 modules and we made it so every single mechanical system ends up in this one area. The idea of modular mechanical systems and prefabricated mechanical systems has already taken off in Europe. Instead of relying on ducts to be installed on site without duct blasting, without leakage testing, we're pushing the envelope and saying, why can't I get my whole air handler? Why can't I use an insider heat pump? Get something on site and not relying and have it be produced in a climate-controlled factory environment. Get the highest performing mechanical system you can. So that is the CORD there. Secondly, we're going to look at the wall system, right? The wall system in a home. We have used a standard wall system in parts of the home and not in others. In the state of North Carolina, I don't know where everybody's from, we are now greatly pushing the use of continuous insulation. How many people here, when they get cold, chews up a sweater and puts it between their ribs? Does anybody do that here? What do we all do? What do you do when you're cold? You're doing it right now. You're putting a jacket on. Is that jacket continuous? Is it covering your whole midsection? Do you have framing members that are stuck between certain areas of that jacket, greatly reducing your R value? No, but we do that in houses, don't we? So our house has flipped the standard envelope around. We look at our batt insulation between framing members as extra. We have a 14-inch wall system. Now, I know that you're going to say, this guy is crazy, and I don't expect you to go home and put in a 14-inch thick wall assembly. But maybe a little R-Max insulation, a half-inch of polyiso, maybe a little structural insulated sheathing behind there, get some continuous insulation, you know. That would be fantastic. So we have 2 wall systems in the home. The one on the right goes over our CORD, standard 2x4 wall system that uses, on the outside of it, we start off with 4 inches of polyisocyanurate insulation, go from that to 4 inches of rock wool, mineral wool insulation. Very heavy European product, making moves to come into the United States. Over that, we put a layer of a zip wall system, and then we're going to use a compressed rock wool rain screen, which unfortunately is only available in Europe. And that's the good thing about being a university. We can do things like that. But a rain screen technology is fantastic. We also have used advanced framing techniques. Unfortunately, we could not take full advantage of them. The 6 pieces of our house have to travel about 6,000 miles independently and work as independent structures. But for the development plan we're working with in Winston-Salem, we're going to look at spreading out that stud spacing. We're going to blow past 16, maybe to 24 inches. That's the beauty of us not using drywall on the interior. A major research project was, let's look at rental homes. What is the biggest expense? And this is a former decathlete in the back, Dave Lee from Lowe's, and he'll tell you they sell a lot of drywall, paint, and carpet. And as a renter, I don't want to replace drywall, paint, and carpet. So we did the easiest thing. We put no drywall, no paint, and no carpet in the home. It's a pretty abrupt choice, but we went with a lot of wood. On the left-hand side, we're using cross-laminated timber. My colleague over here mentioned quick construction times. Cross-laminated timber is a product that came out of Europe in the 1990s, tried to carry on a sample here, and the guys at the Charlotte airport have a nice sample of cross-laminated timber now in their bag. They didn't want me to have a 10-pound brick of wood on the plane. I don't know why. But what it is it takes laminations of wood, and you make a wall that can be up to 19 inches thick of solid timber. You're looking at me and saying, that is so resource intensive. This Yahoo's here telling me it's a sustainable building practice. Well, we're not competing with standard platform framing. We're competing with steel, poured-in-place concrete, tilt-up masonry, and CMUs. So we buy a panelized wall system out of Austria. It arrives on site, and our assembly time goes from 90 days to 2 days, if that. In the UK, this system is used, and they, on average, will frame a 10-story multifamily housing unit in 3 business days with 1 crane, 1 18-wheeler, and 3 workers. I can shrink a construction window 40 to 60%. When you look at that from a retail market space, your at-risk time of your loan shrinks too, greatly reducing construction expenses. However, your upfront expense goes up. On that, we have the same insulation system, 4 inches of polyisocyanurate, 4 inches of rock wool. Polyisocyanurate, why are we using a hybridized insulation system? We love polyiso here in the US. We put it on everything. Well, does anybody know the one negative aspect of the fantastic material that is polyisocyanurate? I love saying that word too. Polyiso. Polyiso is the only insulation technology that's R-value decreases as the temperature and thermal pressure increases, correct? So we put 4 inches of polyisocyanurate right up against our wall. There it is again. 4 inches of rock wool behind it. We've put a blanket over our polyiso. We want to keep that polyiso insulation right at 70 degrees and get that awesome 6.2 R per inch. Our wall systems have an average R value of 46 inches, 45 in the floors, and an R60 in the ceiling. The home is using what we call the passive house technology or passive house building system, which is out of Europe. Blower door testing, we're allowed a 0.6 ACH 50. State of North Carolina code is 5 ACH 50. This has been more air sealing than I have ever done in my life. I repeatedly buy Lowe's out of silicone and caulk, and they don't get it fast enough. But the living brise-soleil, we wanted to look at another technology. The idea of intelligent building skins. We're, especially here in the Southeast, we hear about intelligent building skins. And that means you're going to spend a lot of money often. There's no way about it. You say intelligent building skin, your line item goes up. But all an intelligent building skin does is shade the windows when it has to and let the sun in when it doesn't, right? On the west side of a building in Las Vegas, we don't want that sun coming in at 3 p.m. on an afternoon, driving up our HVAC costs. Well, our students said, what can we go and buy off the shelf and make an intelligent building system? And rain screen cladding. Rain screens, we've purchased all sorts of rain screens in the world, and in the European market, it's coming over to the US and the Canadian market. But how can you build a rain screen with off-the-shelf technology? So instead of $50 a square foot for a purchase system, our rain screen is at about $10.50 a square foot. We believe that if we could make it as a standalone structure, we could get that down to about $5 to $6 a square foot. There's a little interior rendering of the home. Gave up on the drywall, the paint, and the carpet, embracing the wood. You know, I've never heard somebody walk into a house and just say, oh, there's too much wood in here. I don't like that, right? The idea of it is it's a low energy, low maintenance wall finish that if there is a problem, you can sand out. We have 3 7/8 inch wall sections of solid timber, so they're pretty easily serviced. So what has PlyGem's experience been with us, and how have we incorporated PlyGem? We have a long-standing relationship with PlyGem, going from our first solar decathlon in 2011. When we started to go to build a passive house in the United States, we realized something. There wasn't a window provider on the market in the United States that could provide the performance we demand. So we called up Lee Clark Sellers and we pitched a crazy idea to her. I said, myself and Jamie Russell said, hey Lee, We got Eastman South Wall that we're working with, and they make a heat mirror glazing, triple pane, 2 films in it. They don't have anybody that can build us a frame. You guys make frames. Let's try. Let's play ball here. So we've worked with Plygem since the summer. We use the Plygem Canada line, which you can see over there, and we incorporated a very large glazing system into a small window environment. I'll tell you, we have a forklift on site, and I'm glad. My back has thanked me for that forklift. That door weighs about 900 pounds right there. That is the heaviest door I have ever moved in my life. But Plygem has done that. They've been also very innovative in other areas. Lee Clark Sellers is the innovation officer. And when we originally met with them, they have these eco shakes that you can see up here on this structure. Uses basically the dregs of a recycling plant that usually would be landfilled and some agricultural waste. I don't know if you take a sample up here, we have a very interesting academic environment. Not only do we have a building science program, but we have an industrial design program. So Lee sent us some of these decking boards. They also are working with a decking board product and said, can you make us something interesting? Well, we threw a couple pallets of decking boards at our industrial designers, and they came up with some bent furniture here. I'm not going to lie to you. This is the first time I've seen it. My office is next to this wood shop, and by the time I finally got a chance to walk over, they were like, "Oh, Eric, we shipped that last week. You missed it." But this is a fantastic thing that we've done, and we're working always. So the very interesting thing about the Plygem and Appalachian State relationship is they're not afraid to take a chance. They're not afraid to try something new. We've approached them with ideas that many other companies I can attest to have denied outright, and we have realized who a forward thinker and innovator in the building industry is. Now, I don't expect tomorrow that they're going to come out with a quadruple pane window, but we know that their factory can do it. We know that their frames can hold it, and they've supported these young professionals in the building market, and that's the biggest thing is that we have about 1,700 students working on this project right now, currently in Boone, North Carolina. If their first experience is with Plygem windows and doors, who are they going to go back to when they work in the building industry? So the one thing I would stress is, as a starving student, you can take this and leave it however you want, but supporting the younger people in the building industry is a very important aspect.